Okay, hello everybody. Welcome back to the final session of the day, where we are going to have a presentation and a demo. And our first speaker, before I start, that's it. I was reminded, if you have any questions, please put them in the live Q&A so that we can answer them at the end of the talk. So the talk is going to be presented by Shanna Tevort McLeod, and she is talking about utilizing design elements to enhance research communication. So I'll just open the floor to you, Shanna.
Thank you. Yes, I'm Shanna, and I am the design lead at EP Interactive. So today I'm going to go through some easy tips about how you could design a user-friendly dashboard. I'm going to be focusing on a dashboard, but these tips can easily be translated onto a website design or an app or something like that. So I'm going to start off with going over why design is important. Then I'm going to go into the dashboard design process and then look at design principles. So why is design important? So when you're designing something for a user, you want to ensure that their needs are met. So you can look into this thoroughly in the design process. You also want to make sure that it is intuitive for someone to use so they can get the information that they have gone there. You want to reduce frustration. So if someone is trying to use a tool and they can't find what they need and everything is in the wrong place, they're probably just going to give up and leave. So you want to make that as easy as possible for the user. And design can also help you quickly iterate ideas without having to go into all the fuss of if you don't like it. So starting off with the design process. So this is the basic dashboard design process we go through. So you start off by defining your project. Then you go into the planning phase where you could create a sitemap, wireframes, and look into what you want the app to look like. And then we go into cycles of stakeholder consultation and mockups. And we do that over and over again until we reach a final design. So in the project definition phase, you are going to want to have a good idea of the goals you want to achieve with your dashboard before you start designing anything. You also want to define your target audience at this phase, so this can impact what information you display on the dashboard. So for example, if your audience is not familiar with the subject matter that you're showing them, you'd probably want to include more information there. You probably want to simplify your data visualizations. Also in this phase, you'd want to research other tools that are out there. So you can have a look around, see what's out there. You can see things that you like and want to include in your one, or you can see things that you don't really like and want to avoid. Then we go into creating a sitemap and a wireframe. So a wireframe is the rough outline of your dashboard. You can just do this with pen and paper, or you can do it with a digital tool if you like. That just outlines, say, this graph is going to go here, we're going to have some text here. So we roughly outline it and plan out, and then you can see, oh, actually, I don't like that one, and you can change it really easily. This also helps you plan out the hierarchy of elements that you want on each page. Then for a sitemap, so this is basically just the relationship between the pages. So you'll probably have an home page, an about page, a contact page, and then whatever other pages your content requires. So you're just going to figure out how you're going to navigate between these. So a couple of years ago, we created this little fun tool which allowed you to go on a road trip around New Zealand, and at each stop you collected a postcard. So this is the wireframe for that. So you can see up top we have our title bar, and then on our first page, on our home page, we had some introduction text just to explain the context of what you're going into. And then on the main page, we had the map that you travel around on, and then the postcard. Then you can start looking into the look and feel of your dashboard. So for this, you're going to look into the colors, the fonts, the graphic styles, the photos that you want to include. If you are designing for an organization, you probably want to focus on that organization's branding at this phase. You can also create several mood boards with all of these like fonts, pictures, and choose between them if you see one that you like better, or show them to a few people and see what they like. Now we start with stakeholder consultation. So it's good to start this very early, so you can, I guess, test things out before you put too much work into them. So for this, we tend to start off with a very small group of people, and then as we iterate and define things further, then we'll go into a larger group of people. Then we go into our mock-ups phase. So this is where you take your wireframes and sort of combine it with your look and feel and create something that looks a bit more like your final dashboard. So you can do this in programs like Adobe XD, that's what I use. You could also use Figma or Envision. And if you don't know how to use these or you don't have access to these tools, you could always just use PowerPoint. That'll do a fine job of it. Yes, so if we go back onto our road trip, so this is what the mock-ups look like. You can see this is fleshed out. We've got like content in here. You can see the layout and all the colors and everything applied. Then we will repeat cycles of stakeholder consultation and mock-ups. So as we go through, we'll show it to more and more stakeholders to get a wider opinion on it. And then when you're through all of that, you'll have your final design. So this is then just a show of the Adobe XD interface when you share your design. So this can be really helpful for stakeholder feedback. So here you can see in the top corner, you can make comments on it. So this is the way you can collaboratively like comment and talk to other stakeholders on a design. Cool. And then you have your final design. Now, after your final design, you still want to sort of think about design as you go on. So when you are developing it, you would want to take a look at the tool you've developed and test it on different browsers to see if it still looks the same. You want to check that the font color and spacing is consistent and it's pulled through from the mockups you've created. You want to make sure that the flow works once it's actually developed, because sometimes you can't tell when you're just looking at images of the mockup. Cool, and now going into some design principles. Creating a color scheme, accessibility, choosing your fonts, looking at icons and white space. So color scheme. A color scheme creates the mood of your dashboard. So if you choose a lot of blue colors, it's going to look high tech. If you use a lot of green, it's going to look natural. If you use black, it's going to look expensive. You want to have a limited color palette. So if you use too many colors, it's just going to look like a big mess. So you choose your colors carefully. And you also want to think about if you are creating something for an existing brand, use those colors in your dashboard. So when you pick your colors, there's sort of 3 categories of colors you need to choose. So you have your neutral colors. So this is your background, your text. A lot of these will probably be like white or black or gray. You have your primary colors. So these are the foreground elements, the navigation. So this will be probably the main colors of your brand. And then you have bright colors. So you might use a bright color for a notification, like warnings or other important information that you want people to focus on. Cool. So here on the left, you see a color scheme applied badly, and then on the right, you can see it applied well. You see on the left, it's very confusing to see where things are. It sort of looks like a big mess. It's just a bit too much going on. Where in the second image, you can see that we've used our neutral color, so our gray color for the background. We have our primary color, so the blue that is used for the navigation on the left. And then we have our bright colors. So if you look at the books warnings at the top, or the green next to your name to know you're online. Cool. So this is a dashboard that we developed for HPA. It's called the Coupe Data Explorer. So here you can see that we have our neutrals colors, so the white and gray we've used for the background and the dark gray that we've used for text. We have primary colors, so we have, for this, it is blue and green. So you can see up the top, we've used that for our navigation. And then we have our bright color, so in this case, orange. So we've used that for the data visualization and also the info buttons. Next point is accessibility. So first thing to think about with accessibility, especially when you're picking your colors, is color blindness. So on the left is the normal dashboard mockup, and then on the right is one put through a color blindness filter. So it's important to check these, especially for representing data points, because you don't want people to confuse two categories on a graph. So to do this, I always just run it through a color blindness simulator, like the one linked on the slide. Then you look at contrast. So you can see the top green square has really bad contrast, and then the bottom one has good contrast. So I use the WebAIM contrast checker, where you just put in your text color and background color, and it'll tell you if it passes or fails. So I always go for a AA pass. So you can see for normal text in this example, it has failed, but on large text, it has passed. When it comes to choosing your font, so first off, you're probably not going to pick Comic Sans unless you're creating something for a primary school. But then on to serif fonts, so they're the font with the little feet on the end of the letter. Those can look really nice, but also can make your dashboard look like it comes from the 90s, so you have to be really careful with them. So the safest font choice would be a sans serif font. So FontJoy is just a tool that uses machine learning to help you pair fonts together. So if you want to use a different title font to a body font, you can use a tool like that to help you. And then you can, once you have the fonts you're using, create a handful of styles. So you want to keep this very limited to help with navigation. So you'd want a style for headings, subheadings, body text, and links. So you see here in Coupe, we've got our big, bold heading. Then we have a smaller, bold subheading. Then we have these minor headings which are just the same size as the body text in bold. And then we have our normal body text and our links in blue. And then for icons, so icons can really help you navigate an app, or it can replace text and declutter. So we have our basic icons here, so like home, download. These are things that everyone knows, so you can use that to replace a word if you want to declutter. So if you're looking for fonts, Font Awesome is a really easy way to find them. So check it out. Cool. So we see back in Coupe, we've used icons here to help users know where they are or what they've navigated to in the dashboard. So you can see on the homepage, we have a bunch of icons for the different categories. And then we have on each page just an icon representing the category that they're in. Cool. And then looking at white space, so on the left, you can see it's really jammed up. It's really hard to navigate through this. You see in the left panel, it's hard to see that channels is a heading and not just one of the other categories. Whereas on the right, you can see everything has a lot of space. There's a lot of space before the channels heading, so you can see that that's a heading, and there's a lot of space between messages so they don't get all jumbled together. Cool. So that's all I'm going to go through today. But if you want to check out any of the designs and actions, you can check out our webpage. And yeah, thank you for listening. Yeah, if you want to stay in touch, follow us on LinkedIn or email me. Otherwise, we have a masterclass series starting. So we've got R-Shiny masterclasses, Python, and Quarto ones if you want to check it out. Thank you.
Okay, can people see me? Hello? Okay, all right. Yeah, okay, so thanks for the talk, Shanna. That was really interesting, and we even have some questions. It was funny because the first one came from Alexander asking about whether you cater for color blindness, which was the first thing that came to my mind when I saw color scheme, because it's quite a tricky one. But anyway, you did cover that. But we also have a question.
Another thing for color blindness that might be useful is tend to use shades instead of different colors. So then you always know that the lightest one is one category, the darkest one is the different category. So that's another tip that I use quite a lot.
Oh, there you go. And there's another question from Michael, by the way, who's asking, would things like dark mode disrupt the look of the site? And how do you handle people having multiple system themes?
So from what I've found so far, people having dark mode doesn't affect the look of our sites. It just doesn't impact them at all. I haven't really thought about. I have people doing different themes. Again, I haven't seen it impact anything so far.
And we have another question. Are content and look separate in your dashboards, or are they interweaved?
That is a good question. So I think to a degree that they are interweaved. You sort of have to consider everything when you're doing your mock-up phase, how everything works together.
Right. And just another general question is, do you think that, or what are your thoughts on how AI will affect design or, resources for finding images, fonts, etc.? Because that's a big topic.
So with AI's effect on design, there are a lot of tools coming out that are can be very useful, especially non-designers who want to create something. So we have image generators or icon generators are starting to show. I'd say at the moment, still probably wouldn't use them. They can be a bit iffy, but definitely they are getting better. So something to look out for in the future.
Cool. One more question from Maxime. Do you design for mobile separately from wider screen, or how to make a nice transition from one to the other screen size?
So we do separate mobile mockups in the design phase. So when you do those, I think you just have to think about what logically would fit on top of each other. So if you have something that's maybe there's 3 tiles across the screen, do those tiles just go one after the other, or one needs to sit on top and one on the after? So that's sort of the things you need to consider when switching to mobile. It's also important to consider, a lot of people are on laptops, a lot of people have very wide screens, so it will look different at all depending on what screen you're on.
Yeah. Excellent. Okay, so as far as I can tell, there's no more questions. Thank you again, Shanna. Great talk.
Thank you.
Really appreciate it. All right. Okay, so we're now moving on to the next speaker, Wolfgang Hayek, and he's going to give us a demo on managing scientific software with SPAC.
Okay, thank you very much, Vina, and hello again, everyone. So I'd like to introduce you to SPAC. I have a few slides that I need to show you first, so it will be a demo, I promise. So it's only just a handful of slides, but I need to set the stage a little bit. Okay, so I got interested in SPAC about a year ago when I started thinking about what the scientific programming environment for NIVA's next generation HPC could look like. And so SPAC is, I think, about 10 years old now and has gone through quite a bit of a development process over the years. So it is a software management tool, and evidently software management is everyone's favorite thing to do. So I mean, it is a very difficult thing to do. You need it, obviously. So it's a foundation for everything you do. It's complex in many cases. You need to bring many things together, and so you do need to spend the time on getting it right. And SPAC is really a great help with that. So of course we have Conda. Many of us use it. I use it a lot. It's a fantastic tool. It works for a lot of use cases, but it doesn't work so well if you have any specific needs to build from source. And so this is exactly where Spec comes in. And it takes a lot of the ideas from Conda and generalizes it a bit for a build from source environment for HPC, but it's not limited to HPC, so you can use it in any Linux environment, and it might even support Windows. And so there are many use cases where you would want to build from source. You should never build from source if you don't have to, because obviously you don't really want the complexity unless you can't avoid it. But in many cases, you do need it. So if you have particular performance needs for particular hardware, if you need a particular compiler to build things with, Fortran is one of these examples where you need to take care of your build environment. And so a spec comes and helps you with that. It has a lot of features, so it's quite a complex package. So it, as I said, it caters for very specific needs around the build environment and your runtime environment. It has the great feature that in an environment where you have a centrally installed software stack, that users can go and extend this themselves, which is really brilliant. So they don't need to always ask admins to install this or that software package for them. They can just go and extend the existing software as they like. It also supports environments. So if you've used Conda environments before, and I'm pretty sure that many of you will have, in Spec works just the same way. So it also allows you to bundle up software in a particular environment, so that you only have what you really need, and you know what goes into your software environment. In Conda, you can you have channels. You can also build your own private channels, which is pretty easy. So you can put your own software packages there, and Spec lets you do that as well. So you can pre-build everything. Building from source takes a lot of time, so it's a good idea to pre-build, and then you can just put it away into a cache and then pull it out very quickly. So you can very quickly deploy entire software environments within just seconds or minutes. And then it has more features around automation, if you like that. And it's also seen a lot of support by software vendors and cloud vendors. Of course, there's always a downside. So I already said that source builds are complex. There are many things or many ways in which they can go wrong. Also Spec it does come with a lot of complexity necessarily because of the simple complexity of from source builds. So you do need to spend a little bit of time, or I would highly recommend it, to configure it well, because otherwise you might face a complete rebuild when you realize that there is a very important parameter that you didn't set right. You might have to rebuild the entire lot. It's all automated, of course, but it will take you a few hours. And if you're in an operational environment, it might involve a little bit more in terms of the change management. So Spec automatically resolves dependencies for you, and I show that in a minute. And this is highly sensitive. So if you make any change somewhere in your dependency tree, this will filter through, and so you have to be very careful with how you manage these dependencies. Right. Okay, let's get into it. So I'll switch over to my Linux terminal, and the first thing I'll do is I'll check out Spec from its Git repository. So that will take a moment. So this is how you get started. You'll note that I'm selecting a very particular version here that's important. So Spec can't easily mix different versions when you have an existing software stack. So you always have to use one particular version of Spec and run with it and build your entire software stack with it. So once you've built it and you switch software versions, then you will have to rebuild it. Okay, so now we have Spec. Now I'll activate the environment. Very similar to Conda, you have to do the same thing. So you first have to get Conda in your environment, which I'll do with this init script, just like Conda does. And now let's ask Spec, which packages do you have? And they're 0 because we just downloaded it. Next thing I'll ask is, which compilers do you know? Compilers are obviously fundamental to Spec, so they play a special role because they are really at the foundation, because we are building from source, right? So we don't know any compilers yet, but we can make Spec aware of our system compiler. So every Linux should have a system compiler. If not, then you'll need to install it. and spec can automatically look through environment and find that compiler. And that's kind of a bootstrapping approach. So you always start with a system compiler first, because that's your starting point for building everything else. And then you can go and build new compilers with it, or download new compilers and get going from there. Okay. Here we go. Spec found our old GCC version. This is an older Ubuntu image that I'm using here. And Spec discovered the compiler, and it's installed on the system level. I've also have the C++ and Fortran compilers. And now if I ask Spec again, Spec compilers, which compilers do you know? And it tells us, yes, I know a GCC compiler. Okay, let's install our first package. So very simple. Just a spec install, and I go for the zlib package that's in the spec tutorial, simply because it's a very simple package to install and it won't take so long. But still have to wait a little bit of time now, because that's the first time we're installing anything with our local spec copy. And it will have to bootstrap itself, so it needs some additional software that will allow it to resolve the dependency tree. So that's a complex operation. So if you've used Conda before, and if you've given it a very complex environment, you might have waited for minutes, half an hour, 2 hours, depending on how many packages you have there. So that is a bit of work to figure that out. But now within the next few seconds, hopefully it will have done its work. It's always a scary part of a live demonstration, that things can always go wrong. Still thinking about it. Okay, I'll keep talking in the meantime while Spec is thinking. So when it comes to dependency trees, these packages managers use a thing called a directed acyclic graph. So that's how you organize your dependencies. And so Spec defines the software packages in recipes, which are written in Python. And in each recipe, you define which dependencies you need to build that particular package. And then these dependencies might have further dependencies of their own. And so you build an entire tree of dependencies. And so the purpose of this directed acyclic graph is then to basically bring it all together and to then form a coherent set of dependencies, because there may be overlaps between the different packages that your dependencies depend on themselves. Okay, still waiting here. Of course, it has taken unusually long now, so I've run this demo 2 or 3 times before the session to make sure that everything is working, but it looks like it's just letting me wait now. And finally, we have a response. Yay, fantastic. Okay, so what's happening here is that it bootstraps itself, as it says here in this very lengthy URL. So it's downloading some stuff. And of course, this is now also much slower than it is normally. Okay, so yes, we're getting there. Well, at the very least, we can follow very closely what Spec is doing. And now, okay, it has its dependencies. You get a little glimpse at the Spec syntax. I'll tell you a bit more about it in a moment. So this is called the Spec language for Spec. And so it installed its own dependencies to get the solving done. And now it went to the GCC dependency. Every piece of software that you build should depend on compiler runtime libraries that is captured here. And then our zlib library also depends on gmake, which is quite well known. So we're building that as well, fetching so it's all from source, right? So it's fetching the source files from the net and from our spec mirror. And now it's automatically building everything. So the instructions for how to build that, that's all in the package recipe. And then it hands it over to the build system that then gives us our build. And you'll notice here that the package that was installed is a particular version, and it is suffixed with a hash. This is also the same as in Conda. So every single package that you build has a unique hash attached to it. And this is how you can always uniquely identify a particular package, which is very important. And now finally for our zlib, we have all our dependencies, and now it goes and fetches the source code from the net. And it's building zlib. It's a very small library for compression, so it shouldn't take very long. And we're there. Okay, great. Sorry, this is taking so long. Of course, it had to take much longer than ever before, but okay, we got it. All right. Now I asked back again. So, which packages do you know? We have packages. Fantastic. Now, just to demonstrate, if you've used modules before, so if you've worked on an HPC, you're quite familiar with that approach. So if you want to bring a package to our environment, we just load it. And so now if I do a which in gmake, it tells me that gmake now comes from our spec installation, and spec automatically build this entire directory tree. And here's our gmake in that particular version and with this particular hash. That's of course a little bit awkward to use. So if you have a script that needs to make use of a particular location of a package, say if you want to build your own stuff on top of things, you can ask spec, give me the location, which is a portable way of getting hold of this. And we can of course also then install a different version. So we have we can look at the package recipe with the spec info. Now it tells us what it knows about zlib. So we automatically got zlib 1.3.1, but it knows about a few older versions. And so just in case this will take a little while again, I'll set this running now. Okay, let's use 1.2.13. So this can now work away while I'm still talking. Okay, so we have these different versions available, and they're also build variants. So each package, or many packages at least, have different flags that you can set if you want to have a particular build that has this or that feature. So here it is pretty straightforward. You can ask it to build a shared library. You can ask it for some optimization, and you can switch between different build systems. And as you can see here, so now I asked spec a little bit more specifically. I want zlib, but with this add symbol, I can select the version, and now it gives me 1.2.13. And so spec certainly knows how to handle multiple versions of the same package, which is quite useful. So our little package repository here now has the two different versions installed. And now if I just do a spec load as before, I now have two different versions of zlib. So spec tells me like, nah, sorry, you need to be a bit more specific. So I can either do a spec load at, say, 1.2.13 that works by specifying the package version, or alternatively, I can load it with the hash, because the hash is always unique for each package. So I can just do it like that. And now if I ask it, okay, which package did you actually load? It's zlib 1.2.13. So hashes are a bit awkward for people to use, of course. So it's often easier to understand the a spec syntax where you specify name and version and so forth. But the good thing about the hashes is that they're always unique, so you can't get it wrong. Okay. Now let's look at a more complex example. So say we have NetCDF Fortran, which a lot of people use. It's a very popular package, at least in the weather and climate community. And we can ask spec which dependencies are needed to install NetCDF Fortran. And so this will take a moment again, because now we're going through our directed acyclic graph and, and putting all the different dependencies together. But hopefully in a few seconds, we'll hear the answer, or we'll see the answer. Yes, there we are. And so here we have all the different packages that are needed to build that. And now we can customize it a little bit, so we can turn things on and off. You'll see here that it defaults to the MPI version of NetCDF. So we'll get that. That's why there's so many dependencies. Okay, I'll quickly show you how to extend an existing installation. So I've put one there before. So that I'm just referencing now. So that's a separate installation. That's a stand-in for a site installation of a spec environment, or sorry, as a spec repository. And now you can see that we have all these additional packages all of a sudden. And now finally, I'll create an environment. So here I just list the packages with the hashes. I create a new environment. Just like in Conda, I give it a name. Then I'll have to activate it. If I do a spec find now,
Marcus, now's not a good time.
I'll see that there are no packages installed, and now I can take a package. Say I take the netcdf package, and you'll note that I specify netcdf both with a version, a particular compiler here in this case, and with its hash. I'll install it. Almost at the end now, by the way. This will take a few seconds. And installation means because this package is already installed, I will just symlink it basically into my environment. And then I'll end up with an environment that has everything in it that's needed for NZRSE. Okay, here we go. All installed. And I can give you a quick look at the environment description file that spec creates, and that's important here. So spec takes note of what I asked for. I asked for netcdf, and because I use the hash, I get exactly the version of netcdf that I had in mind. And now if I do a spec find, netcdf is there with all its dependencies. Okay, final slide. So here are a few tips and tricks that I developed over the last year as I've been using this. So just if you're interested in spec, then please have a look at this. It might help you a little bit with getting going, because again, the learning curve can be quite steep. So there are a few things that you need to get right, but it is a fantastic tool. So I really recommend using it. And thank you very much.
Well, thanks, Wolfgang. That was actually really great to watch, especially because live demos, as you said, always have their moments. So there's no questions currently in the Q&A. So I'll just come up with one of my own. Do you want to share any more details about how, like, what software or cloud vendors support SPAC? Like, what support for SPAC is out there?
So SPAC was developed at, I think, an HPC site in the US somewhere. I think it was Los Alamos or one of those. And over the years, it has become more and more popular. So you now find it in HPC sites all over the world, and different companies have also started to support it. So say if you look at Intel, and I'm guessing that NVIDIA, for example, support this too. So they'll give you a hand with making recommendations for using their tool chains, say the compilers, libraries, and so forth with SPAC. So how do you install it? How do you make the software known to SPAC to use it in the best possible way. Then you get support from cloud vendors like AWS. So AWS started building a big SPAC mirror with readily built packages, so you don't have to build them yourself. You can just pull them out of this mirror repository, or this binary repository, which shortcuts the build process quite a bit. So building a whole software stack can take many hours depending on how many cores you have. But if you can just pull it out of the repository similar to Conda, it can take just, I don't know, seconds or minutes or so.
And you can also use SPAC to build containers?
Yes. So it's also a good way that if you want to create a new container and you need a software environment for it, you can ask SPAC to give you a container build recipe automatically. So you create an environment in the same way as I've just shown you. And then you can ask SPAC, hey, give me a Docker container recipe for installing these packages, and it will produce one for you. And you can just copy paste that into a recipe that you run with Docker, and then there's a container. So it can be really quick and easy to build an entire container out of this.
Nice, great. Well, thanks for telling us about it, Wolfgang, and thanks for your talk. Cheers. Yeah, there's no other questions in the Q&A, so. Okay. Just quickly, all attendees, if you could just refresh your timeline before you go to the Birds of a Feather session, that would be great. Thank you.